As we move into section 5 of chapter 5, you're going to learn about this thing called different roots of polynomial equations. Now, something kind of to tell you is the root of an equation is where it crosses the x-axis. Okay, so if I ever talk about a root, that's what I'm asking about. I'm asking about when does it cross the x-axis? That's its root. Y would be 0. Now, there is a theorem, and today what you're going to use today a lot when you can't factor. Okay, so today we're going to have a lot of problems that you're going to see you can't factor with. So we're going to learn about this thing called, and this is a fun little activity to get you warmed up if you want to pause and try it. We're going to learn about this thing called the rational root theorem. Now, what the rational root theorem does is it helps us figure out a fraction or a whole number or an integer or some type of regular old number where it crosses the x-axis. Now let's say you're given this general equation, 21x squared plus 29x plus 10. How do you use the rational root theorem? You think of all the factors of 21, plus and minus 1, plus and minus 3, plus and minus 7, plus and minus 21. And then you think of all the factors of 10, plus and minus 1, plus and minus 2, plus or minus 5, plus or minus 10. And then what you're going to do is I'm going to teach you how you're going to put items, and it says you're going to put P over Q. I'll show you what that means in a little bit. And you're going to figure out which ones equal 0. You're going to put these factors over here, put these factors over these factors. You'll plug them all in and you'll see which ones equal 0. In this case, only 2 of them did. I'd like to write the steps out so that you have something to refer to. Step number 1, find all the factors of the leading coefficient, which means the one in front of like x squared or x cubed, the biggest degree, the leading coefficient and the constant. After you find all the factors of both of those items, you're going to go to step 2. Now really this is 2 steps in one because you got to find the factors of the leading and the other one. You will put all the factors of the constant over all the factors of the leading coefficient. Okay? Step 3, you're going to plug every item in. Item or fraction or whatever you want to call it. You're going to plug in everything from number 2. You're going to plug everything you get from number 2 in. And step 4, the ones that equal 0, are the roots. Then in step 5 today, after you find one root, so you don't have to keep going, but after you do find one root, you can then use synthetic division to find more. So if you don't want to sit there and plug them all in, after you find one that equals 0, you can then move on to use synthetic division to find the others. Problem 1, and we'll do the got it in class. It says, what are the rational roots of this? Now, notice this is rational roots. What that means, guys, is we are not finding any imaginary. So the only thing this thing is good for is finding rational roots. It's not good for finding imaginary roots. Okay, following your steps from the front page. Step number 1, find all the factors of the leading coefficient and the factors of the last. So I'll write number 1 here, and I'm actually going to do number 1 and number 2 at the same time. Okay, I'm going to draw a big fraction bar, and on the top I'm going to put the constants, the factors. I'm going to put the factors of the constant on the top, and then I'm going to put the factors of the leading coefficient on the bottom. Okay, here we go. The constant is 5. The leading coefficient is a 2. So the factors of the constant are plus and minus 1 and a plus and minus 5, because 1 and 5 go into 5. The factors of the leading coefficient are plus and minus 1 and plus and minus 2. Now what that means for step 3 on our paper, let's see, our step 3 was plug every single item in. Step 3 is step 3 is annoying. You ready? You're going to plug in every item on here. So you're going to do, I like to make an XY chart. It helps me to see it better. Okay? You're going to do 1 over 1 is 1. 1 over negative 1 is negative 1. 5 over 1 is 5. 5 over negative 1 is negative 5. 1 over 2 is a half. 1 over negative 2 is negative 1 half. 5 over 2 is 5 over 2. And 5 over negative 2 is negative 5 over 2. So those are all our options. I guess the box didn't have to be that big. When we do the got it in class, you'll see that one's actually a lot longer than the other. In fact, you might want to get a start on it. Okay, I'm going to get rid of all this because we don't need all the extra box there. Okay, so what I got to do now is I've got to plug them in to get my y's. So I'm going to cheat. I'm going to go to my y equals my calculator. I'm going to type my original equation in. 2x to the third power minus x squared plus 2x plus 5. So I've got my equation in. Now I'm going to go to my table, just like I taught you. I'm going to type all of these options in. So 1, negative 1, 5, negative 5. I'm going to write my answers down. 1 gave me 8. Negative 1 gave me 0. 5 gave me 240. Negative 5 gave me negative 280. Really big. 1 is negative 1. I already did negative 1, didn't I? Alright, now I got to go to the half. 1 half, negative 1 half, 5 over 2. Let's see. 1 half gives me 6. Negative 1 half gives me 3.5. 5 over 2 gives me 35. And the last one I need to do is negative 5 over 2 gives me negative 37.5. Alright, so I plugged them all in. Now, take a look at the one that gives you 0. So, if we follow our steps, step 4 says, the answers that give you 0, there's step 4, the answers that give you 0 are the roots. So what I can write are the rational roots. So step number 4, negative 1 gave 0, or outputted 0, whatever you want. So, negative 1 is we'll write x equals negative 1. X equals negative 1 is what we call a rational root. Now what I'm hoping you guys remember is that this equation should have 3 answers. We only got one of them to be rational, which means 2 of them are either imaginary or irrational. We'll do the got it together in class. It will be a lot longer. Sorry about that.
Okay, my estudiantes, we are going to look at problem number 2. I made a new video for this because I just think like I can do a much better job than I did in the past of simplifying it. So we have a polynomial with a degree of 3. So there are 3 potential rational roots. Let's go ahead and write that down. So this 3 means there are 3 potential rational roots. 3 potential rational roots. Now, I'm not saying they're all rational. They might be rational, they may not be rational. But there are actually 3 roots. Some might be imaginary, but there's 3 potential rational roots, 3 altogether. All right, so what we're going to do first, check, is it in order? Yes, it is. Check, is it equal to 0? Yes, it is. It has to be equal to 0. Hopefully you're listening, otherwise you're just watching me randomly circle a 0, but it has to be equal to 0 to do this. So what we do now is we do plus or minus the factors of 2. So the only factors of 2 are 2 and 1 over plus or minus the factors of 15. So we can do 15 and 1, 5 and 3, and there are no other factors of 15. So 2 and 1 for 2, 15, 1, 5, and 3 for 15. Now we grab our calculator. And you can plug these in by hand, but like that would be painful. So if I hit y equals and I put these in, 15x to the third minus 32x squared plus 3x plus 2, and I hit second table, I can plug all these numbers in as fast as I want. So I'm going to start by plugging in like the normal numbers, like 2 over 1 and 1 over 1. So I'll plug in 2 and 1 and negative 2 and negative 1. All right, so the only 0 I currently see, let's see, does this help if I turn that on? Ugh. Yeah, sure, why not? Not really, does it? Okay, the only one that yields a 0 is this 2 right here. So I'm going to write that I found one of my roots is 2. Now, you can like do synthetic division now with that to get the other ones if you want, but you don't have to. We can keep going through because it just asks about the rational roots and not the imaginary ones. So let's see. Let's try like 2 over 15 and negative 2 over 15. Well, that's no good. Let's try 2 over 5 and negative 2 over 5. That's not good. Now let's try 2 over 3 and negative 2 over 3. That's not good because I'm not getting 0. I'm looking for 0. Okay, let's try 1 over 15 and negative 1 over 15. That's not good. Let's try 1 over 5 and negative 1 over 5. Ooh, that one worked because I got 0. So I just tried negative 1/5 and got an answer. All right, so 2 of them are rational so far. Let's see if we can find another one. Let's try 1/3 and negative, oh, there it is. 1/3 popped up as a 0, so I got my other one. I know that I could only have a max of 3, so these are all 3 rational. By the way, just to give you a memory recall, they all have a 0 multiplicity of 1 because they only happened once. So there they are. Now you could do that with synthetic division, but this was way easier, okay? So let's take a look at part 2. It says, what are the rational roots? So I'm going to do the same thing. Check that it's equal to 0. Again, hopefully you're listening. Otherwise, this is a random equals 0. It looks like I look like zeros. We will do plus or minus the factors of the last number, which is 6. So 6, 2, 3, and 1. And then the factors of 2, 2, and 1 on the bottom. So I'm going to check things like 6 over 2, which is just 3, 2 over 2, which is just 1, 3 over 2, 1 over 2, and so on and so forth. Let's see how many. Remember, there could potentially be 3. Potential, not exactly, necessarily. Go to y equals, and you could type these in by hand, although that would be painful. So I would not encourage it. If you have a graphing calculator, utilize your tools. So there's my equation, second graph to plug them in. Again, you could be doing these by hand. I am going to try plugging in 6 over 2, which would just be plugging in 3 and negative 3. Okay, those definitely didn't work. So now I'm going to try plugging in 6 over 1. So 6 over 1, negative 6 over 1, which is just 6. So those don't work. Now I'm going to try plugging in 2 over 2, which is 1 and negative 1. Ah, I got 1. So negative 1 gives me 0. Negative 1 is one of them. Now again, you could do synthetic division with negative 1 if you want. And then when you get an x squared, You can just do the quadratic formula after that. But I'm going to sit here and I'm just going to kind of keep guessing. I did 3 and negative 3, but I don't think I did 1/2 yet. So let me try 1/2 and negative 1/2. Okay, those did not work. Now I'm going to try 3 over 2 and negative 3 over 2. Ooh, there's negative 3 over 2. Negative 3 over 2 gave me a 0. And that came from this 3 and that 2. So negative 3 over 2. So far I have 2 answers. Now let me see if I can get my next answer. I'm going to try, did I try 1 over 2? I feel like I'm missing 1. Maybe I should cheat and look at my old answer key. But let's try. So we did 3, we did negative 3, we did 2, did we do 2 and negative, did we do 2? Aha, look at that. 2 gave me 0, so I wasn't finding it, but it's because somehow I missed plugging in a positive 2. So I found all 3. Those are my 3. They're all rational. Again, if you want to do synthetic division, break it down to an x squared, use your quadratic formula, you could. All right, let's take a look at this problem here. But I think my old video does a good enough job doing this one, so I'll lead you to my old video.